Hello guys, welcome back. So we got a laptop for repair. The problem with this laptop, it doesn't charge. So it will work with the battery, but it doesn't work both with both the power source. Okay, now let me plug in the adapter. So this adapter is 130 watts, but this laptop requires only 65 watts. Anyway, it is higher than the required wattage. Anyway, it's fine. So just to check whether the adapter is okay, in order to find any problem with that, so we'll just connect and check it. So as we know, on the Dell laptops and HP laptops, they have the PSID and adapter ID detection. So if you plug in the original adapter, it will show in the laptop whether the charger is its Dell charger and the wattage of this charger. So at least you should use 65 watts charger for this laptop. So now I'm connecting 130 watts charger, and there is a circuit in this motherboard which detects the charger wattage, and it will inform to the motherboard, then only it will execute the charging. So we can see it on the BIOS menu whether the adapter is detected. Okay, now let me turn on the laptop. Okay, it's turned on. Now I have to go to BIOS menu so that I can see the information of the charger. Yes, yeah, you can see on the adapter the charging wattage shows as 130 watts. So the one-wire circuit on this laptop is working fine. So it's one wire, which means it uses only one line to show that the information of the charger to the laptop. So that line is working fine. Then only we will be getting this 130 watts about the wattage of the charger. So there's no problem in that line. So if we have any problem in that line, it will show a warning notification on this laptop that the adapter that is connected to the laptop is not the Dell original charger. So even though we connect an original charger, if we have problem in this one-wire circuit, it will show that there is no adapter connected. But anyway, we are having the charger, the wattage is connected, the wattage is okay with this charger. So there's no problem in that circuit. Now we have to go to the charger section, which means the charging IC, and diagnose whether there's a problem in that side, and let us confirm it. Okay, so now you can see clearly in this area the battery notification shows as it is charging. Yes, it says 42% available, plugged in and charging. Okay, let me wait for a second or some time to see whether there's an increase in the battery percentage. Actually, now I am using the adapter, so I can't see any power consumption. So if I use the power supply, I can see the changes in the power. But anyhow, I don't have the PSID connector with me for the power supply, so I am using the adapter here. Still it is charging. So one thing we can confirm, so this charging notification is given by the PCH with the help of EC chip. So the EC has started charging function, so it will send system data and system clock signals to the charger IC in order to execute the charging. So we are having the signal enabled by the EC chip, because that's why it's showing as charging, but the charger IC is not allowing, or it's not executing the charging function. So that is the problem in this section. Okay, anyhow, I will show you the light indicator here. So we have 4 indicators, and you see on this line we have the battery indicator. It shows white. White means either it is fully charged or it is not charging. But if it is charging, it will be showing as orange LED, but we are having white LED. Yes, there is no change in the battery percentage. Okay, I think it's not charging, so we have to focus on the charger or the charger IC and its check sections in order to see if there is any problem. Okay, now let me open the laptop and take out the motherboard and let's see what is inside. Okay, now the board is out. I'm going to connect the adapter now. Okay, now the adapter is connected. We'll do some basic checkups on battery connector and see whether there's a main power rail and also system data, system clock voltages on the battery connector. So we have 2.3 volt, this is positive line, okay. 3.3 volt, 3.3 volt, 3.3 volt. Yes. So the two 3.3 volt is for the system data and system clock, and the other one is for battery present. So everything is okay. Now let me connect the battery. Yes, the battery is connected. Yes, we have the voltages on the system management bus, and also the battery present signal went to low logic, so in order to detect the battery. So that is okay. Now we have to check the system data and system clock line with the oscilloscope in order to see if there is any reading on the system data. So we can see whether there is a communication between the EC chip and the charger IC in this motherboard. Okay. Okay, now you can see the display of the oscilloscope in the screen. Now I will connect the adapter. Okay, the adapter is connected. So we need to just check whether there is any communication between the battery, system data, system clock line. Yes, we do have the reading. Now you can see the battery is communicating with the charger and also with the EC chip. So that's why we are getting information on the taskbar about the battery percentage. So that is okay. Yes, there's a communication. So on one pin we have the system clock, and on the other pin we have the system data. So there we have the data. Okay, now we have to check on the charger IC whether we are receiving the system data and system clock line. Okay, before checking with the oscilloscope, let us check the basic switching of the first and second MOSFET. Okay, now the first and second MOSFET is on the other side of the board. I have to turn this side. Okay. Okay, so this is the input and it comes to this place here, this inductor, and goes to this side. This is the first MOSFET and comes to the second MOSFET here and goes to this current sense resistor. So if we check at this point, we are having 19.66 volt. At the adapter side, we are having the same voltage. So there is a switching in the MOSFET. So let me check the gate voltage. Yes, it's a P channel MOSFET, so we are having 8 volt on the gate. On the other MOSFET here, yes, we are having 8 volt. So both MOSFET are switching properly. So we are getting 19.66 volt. Okay. Okay, now let's go to the oscilloscope and check the waveform to see whether there is any communication between the EC chip and the charger IC. Okay. So here's the charger IC. So I have connected the adapter now. Let me connect the ground probe of the oscilloscope here. Pin number 9 and 10. So here we have the mark, so which represents the pin 1. So pin 1, 2, 3 up to 8, so it's 9 and 10. So we can check at this point here. Okay, we are getting a strange signal there, so we are not having 3.3 volt at least. You can see on the oscilloscope, so there is a strange signal, so this is not representing the system data and system clock. We should see similar as earlier on the motherboard that we were checking with the battery, so that should be similar to that. So if we are checking the system data and system clock, so it should be like this. Now you can see yes, so this is the signal. The signal should be like this one, so this is fine, but this one is inappropriate. It's here, it's inappropriate. So let me check on the other side of the resistor. Yeah, we are getting the same. So there's no voltage on that line, so we should get 3.3 volt there. Okay, I was measuring the wrong pin earlier, so this is, yes, the pin number 8 is on this side, not on that side. So we are having 8 on this side, so it's 8, 9, 10, so it's on the second pin of this side, so I have to check it. So now you can see the oscilloscope in the screen, it's visible to you. So I'm going to check this pin here to see the reading. Yes, we do have the reading. It says that it's charging. So there's a reading on the display, you can see on the oscilloscope. So we have both the system data and system clock. So this is clock signals, so we have a beautiful clock signals. Check the data. Yes, we do have the data also. So why the charger IC is not executing its charging function? Now we have to check the requirements of the charger IC in order for it to execute its charging function. Looking at the charger IC of this motherboard, which is ISL 88731C. So this charger IC having a SMbus level 2 battery charger. So let's go into the pin details. So first of all, we need to check the pin number 2, which is the AC in signal. So normally this signal will be from 2.4 to 2.6. So which is to inform the charger IC, or for the charger IC to detect whether there is an adapter plugged in the laptop. So we can check that signal from this pin here, pin number 2 here, we can see it. The other signal we need to check is the V reference voltage, which is on pin number 3, so which will be about 3.3 volt. So when we are getting this V reference voltage output, we can know that the charger IC is alive and it is working. And also we need to check pin number 9 and 10. We have already checked that, which is the system data and system clock line. So on the pin number 11, so which is known as the SMbus interface supply voltage input, so which is the supply voltage for the charger IC in order for these two signals to control. In order for these two signals to execute inside the charger IC, we need to give this 3.3 volt into the pin number 11. So we can check that also at pin number 11, so which is 5 volt always, which comes into this charger IC. So we have to check that also at pin number 11. Then we move on to AC OK. So in pin number 13, so this AC OK is pulled high when there is AC in is between 2.4 to 2.6. So we should have a high impedance at this point, which should be 3.3 volt. So here we can see at this point at pin number 13, here we should have a high impedance or at least 3.3 volt. Then we can check pin number 20, which is the lower gate, which means the PWM signals that is given by the charger IC back to each MOSFET. So we need to check this using the oscilloscope. So all the gate signals and PWM signals we can check using the oscilloscope. So just for the sake, we can check with the multimeter whether we are having all the voltages and also the resistance values of each resistors and capacitors and diode values for diodes, so that we can confirm that component surrounding the charger IC is working fine. So on the pin number 21, we are getting VDDP. So it's very important signal or the voltage, so which is a linear output from the charger IC, which is around 5.2 volt. So we need to check this because it's very important for the charging function. So on pin number 22, we will be getting the main supply for the charger IC, which is around 8 volt to 26 volt. So we need to check that also. Then we have the phase, we have upper gate, boot. So these all are, we need to, from this point here, the upper gate, lower gate, boot, these pins we need to check using the oscilloscopes. So on the other hand, we have the VCC on pin number 26, which is the supply input for the analog circuit of this charger IC. So this is used or bypassed with 4.7 ohms resistor. We need to check that this ohm resistor is well intact in this appropriate value, so it should not increase. If it increases, there will be a problem in the internal circuit or might be a charging function problem. So we need to check these resistors whether it is in 4.7 ohms. Okay, so this VCC input is normally for the driving for upper gate of the MOSFET. So this 5 volt goes into the charger IC in order to drive the upper MOSFET and also the lower MOSFET. So the driving strong or the driving power for the upper and lower MOSFET is given from this voltage here, from pin number 26. So this is supplied from the VDDP. So pin number 21 and 26 is connected from the outside using a resistor in between here. So it is connected straight to the 26th pin. So we need to check all these in the schematics and see whether we are getting everything correct, so that we can move further. Okay, now we need to check every pins that is required surrounding the charger IC in order to see whether its requirements are fulfilled. So now I am connecting the adapter. Right, first of all we need to check pin number 2, which is the AC in signal. Pin number 2. Yes, it's at this point here. Yes, we are getting 3.1 volt. So which is appropriate. So we will be getting around 2.4 to 2.6 on BQ ICs, but this is intersil IC, so this is okay. So we are getting 3.1 volts, so that is fine. Yes, we are getting the same voltage at pin number 3, so it's 3.1 volt. Okay, next move on to pin number 11. We are getting 5.1 volt at pin number 11. So and it should be 5.1 volt. It's around 5 volts, so that is okay. It is the supply for SMbus, so that is fine. Pin number 11, yes, it's 5 volt. Okay, then move on to pin number 13. On pin number 13 we should get 3.3 volt, which is the adapter sense output signal. Pin number 13. Yes, we are getting 3.1 volt at pin number 13, so adapter sense output is okay. Yes, on pin 21 we are getting 5 volt output, so that is also okay. Now on pin number 26 we need to check the voltage and also the resistance value of that resistor. So on pin number 26, yes, we do have 5 volt at pin number 26 also. Okay, now we have to check the resistance value of that resistor there. It should be 2.2 ohms. This is the resistor. Let me check it. Yes, and the value is appropriate. It's 2.7, 2.4 volt. Sorry, 2.4 ohms. So that is also appropriate. Okay. Okay, so here we have both upper and lower MOSFET of the charging circuit. So this is the upper MOSFET and this is the lower MOSFET. So the upper MOSFET source is connected to this inductor and the drain of this lower MOSFET is connected to this inductor, and both will be in switching and generate a voltage in order for the battery to charge. So now I am going to check the gates of these two MOSFET with the oscilloscope and see if there is any frequency or reading, and also I need to see whether there is any waveform in this inductor here to see whether there is any switching happening. Okay, now you can see the oscilloscope in the display. Now I'm going to connect the oscilloscope's probe in this area and see the reading. Yeah, we do have some reading, but it's not correct. So there's the PWM is not appropriate. The waveform is not good. Let me check the gate of the upper MOSFET here. Yes, they are reading the same. Why is that? Is it a problem with the MOSFET or with the charger IC? I don't know. But this is not appropriate. The switching should be different. So I'll show you on the standby section. So this is the standby coils, 5 volt and 3 volt. So now I'm going to probe in one of the side. Yes, you see, this is the appropriate frequency. This is correct, but that one is not correct. This is correct. Okay, so the frequency of the PWM signal should be similar to this one here. Yes, so why is that getting that type of frequency? We need to trace that. Okay, let me check the voltage on the drain point with the multimeter. Just to see in case if there's anything. Oh, we are getting 15 volt. This is strange. Let me check the CSR. No, on the CSR we are getting 19 volt. But on the drain point we are getting 12 volt. Why is that? This is not appropriate. This is not appropriate. So if you look closer, so this MOSFET is straightly connected to this big wires to this inductor here, and this inductor is straightly connected to this point. This is the CSR. So why we are getting 17 volt or 12 volt at this point, but anyhow we are getting 19 volt at this point? Maybe this guy became faulty. Actually we should get 0.00 because it's an inductor. Yes, we are getting 530. It looks like a MOSFET. No, it's wrong. It's faulty. We have to replace it. It's reading 1 mega ohms. Yes, it's reading 61 kilo ohms. Oh my god. So this is the problem. So here I have a same motherboard. I can replace this coil here in this place so that I can see whether it is working fine. First of all, I'll check whether this coil is okay. On this probe here. Oops, I have not probed correctly. Yes, it's 0.2 ohms, so it's okay, it is fine. Right. I think it's a simple solution. So we need to diagnose it properly and identify the fault. Then only we can easily solve the problem. We should not make anything more complex. Okay, it's fixed in its place. Let me check again with diode value or ohms value, never matter. Yes, we do have 0.00 ohms. So okay, let me cool down the board a little bit. Meanwhile, I can clean the board with the isopropyl alcohol. Oh, it's boiling. Let me check again with the multimeter. $19 volt. 19 volt. Okay, fine. So now let's check whether battery is charging. So we can check just with the voltage here. So it's at 15.97. Yes, it's increasing. You see, it's increasing. Yes, it's increasing. Very good. Yes, the voltage is little by little increasing. Okay, now let us see with the oscilloscope. So you can remember the frequency that we saw earlier before replacing this inductor. We are getting a strange signal there. So now we have replaced the inductor. Now we can see the reading, how it is now. Okay, now the oscilloscope is visible to you. Yes. Yeah, now you can see there's a small different kind of waveform than earlier. It's very clear now. You can reverse the video and see how it was earlier, but now you can see there's a clear PWM signal. So the only problem is with this inductor here. Yes, the upper MOSFET is also switching correctly. Everything is fine. Good, very good. Okay, we have solved the case. So now I will assemble this in the motherboard and check whether everything is fine. So everything is now assembled inside the laptop. So now I'm going to connect the adapter here. Right, so let's look at the light indicator in front to see if there's, yeah, we are getting white LED. So it means that the laptop is not charging. Anyway, we saw that it was charging with the oscilloscope. So let me turn it on and see. So I don't remember whether these types of laptop used to show orange LED or white LED while charging. Anyway, let's see the notification in the taskbar so that we can confirm it whether it is charging or not. I'm 100% sure, so it is charging because already we have checked with the oscilloscope, so that is no problem. Yes, you see the percentage. Earlier it was 42%, now it's 47%. So this is okay. So let's see whether there's an increase in the percentage. Still it is 47%. Yes, it's now 48%, so it's charging. So right, we have solved the problem. So thanks for watching. So stay tuned for future updates. So bye for now.